electrons around themselves. What rule are they trying to obey? That rule, yeah. Okay, so excellent. However, there are always exceptions to the rules. Right? There's always exceptions to the rules. So obviously, the top two on the periodic table are one of those exceptions, right? Hydrogen and helium. They only want two. Okay, they only want 2 valence electrons, and they're happy. Okay, so they fit in that category of fewer than 8 valence electrons, right? So the other two that you need to be aware of, that you want to be aware of, is beryllium. That only wants 4 valence electrons. It's happy with just 2 bonds. And boron, which is happy with just 6 valence electrons, or 3 bonds. Okay, Be and boron. Okay. All right, those guys are fine with less than 8. Right. Then pretty much everybody else wants 8, and they'll do what they can to get 8. Double bond, all that sort of stuff. Now there are some atoms on the periodic table that can handle more than 8 electrons, but they have to be big enough. So where do they have to be in the periodic table? Does anybody remember without even looking? You remember, Alex? Yeah.
D orbital shell.
Okay, so what energy level? Yeah, there we go. We got to be in the 3rd row of the periodic table or below. Then you can have what's called an expanded octet. So that atom's totally happy with more than 8 electrons. Could be good with 10 or 12. Okay, but you got to be in the 3rd row of the periodic table or lower, and you can have up to 12 electrons. Okay, you can have up to 12 electrons in it. Now, there are a couple other funky compounds out there that are known as radicals. So they have an odd number of electrons. So like free radicals and things like that in your body that you hear about. Okay, they're stable even though they have an odd number of electrons, and that's okay. All right, but that happens very rarely. It happens every once in a while. Okay, just try to get those atoms to get as close to 8 as possible. Maybe they end up with 7. That's just the way it is. All right, that's okay. Okie dokie. All right, so let's draw some Lewis dot structures. Let's go ahead and we'll draw some Lewis dot structures here. So I'm going to start with, so this is going to be on the back side of your paper where are the instructions. But I'm going to start with something really simple. All right, we're going to start with methane. Okay, CH4. It's not one of your examples. We're just going to kick this one off with this. That's the rust off here. So really important though, we got to do your bookkeeping, right? Okay, make sure you do your bookkeeping. That means I'm talking about keeping track of electrons. And we want to add up the total number. First thing we want to do is add up the total number of valence electrons in a molecule. Okay? Total number of valence electrons in a molecule. So, how many valence electrons are in a carbon? 4. Okay? So we have 4 hydrogens. So each hydrogen has 1. So we have a total of 4 from hydrogen, and we've got a total of 8 electrons. Okay, we got 8 valence electrons to dish out. Make molecule. Okay. Next thing it says there, the second step, we want to put the lowest electronegativity atom in the molecule in the middle. Okay, or in this case, sometimes it's totally obvious. Okay, since hydrogen can only have 2 valence electrons, right, because it's one of our exceptions, how many bonds can it form? 1, right? Hydrogen only forms 1 bond. You can't bond all the other stuff that's there, the 4 other atoms, right? That's no good. There's no way hydrogen could go in the middle, bond to other things. It's a terminal, it's a dead end, right? Okay, so we're going to put carbon in the middle. All right, we got to put carbon in the middle. Do you guys remember about electronegativity and like what the deal is with that? One of our periodic trends. So remember electronegativity? Okay, well, here we go. I'll just bring up an idea. This is the first problem on your homework. Asking about electronegativity. Who's in reading? That's okay. We're doing fine. Okay. So electronegativity is the ability, okay, of an atom to attract electrons to it and bond. Okay. Who on the periodic table so badly wants one more electron so they can be like a noble gas? The halogens, and who of all of the halogens wants it the most? Fluorine, yes. Fluorine is so electronegative. Okay? Massively electronegative. The one who is least electronegative on the periodic table is francium. Francium, kind of like the wars they fight. They just surrender their electrons. Okay? All right? Oh, yeah. All right? So, right? Like that. A little world history there for you. Okay? That's right. Cross-curricular. All right? But francium on the lower left-hand side of the periodic table there, right? If we think about all the stuff we've been talking about, low core charge, way down there, seventh, that electron's super far away from the nucleus too. It's like walking around like, no, really, take my electron. Just take it. Has no affinity for the electron. Okay? Where fluorine is the total opposite. It will hog all of those electrons and want them really badly. Okay? So electronegativity goes from lowest in the lower left-hand corner, increasing all the way up to fluorine. Okay? Closer you are to fluorine, more electronegative you are. Okay? All right. That being said, back to the notes here. Okay. So we're going to shove carbon in the middle here. All right? And we're going to surround it with hydrogens. And we're going to draw a single bond between each hydrogen and the carbon. Okay. How many electrons did we use up there to do that? 8. Because each bond represents 2 electrons, right? So minus 8. I have no electrons left over. Okay. So if we look at our molecules here, well, look at our molecules, look at our atoms. Are each one of them happy in terms of the number of valence electrons around them? Yeah, they are. We're all good, right? Each hydrogen has 2, right? Each hydrogen has 2 by it, okay? And the carbon there has 2, 4, 6, 8. All right, so it's happy. It's good to go. They don't do that here anymore, do they? So, sorry, I didn't mean to do that. Okay, just kind of happened. Just happened organically. Okay. It's a carbon molecule too. On fire today with the puns. They're running deep today. Okay. Where was I going with that? That's it. What's up?
Oh, do you know what zero gravity was?
Like zero gravity on 75th Street?
Yeah.
Zero gravity?
Mr. Connolly goes to the denim stand today.
I've never been there, actually.
Yeah, neither have I.
Thankfully enough. But like kids when I was in high school would go from I'm from Palos, Moreland Park. I went to Sandburg. So kids would go out to zero gravity for like their Saturday night. So, yeah, man. Yeah. But it was an underage club, you know what I mean? Like, so, like, you couldn't be older, really, until they opened it up to older people, which is also kind of creepy. Right? They opened it up to older people that were, like, older than 21. Like, it was an under 21 club for when I was in high school, and then it actually turned out, then they were, like, opened it up so there was people that were older than 21 going there. That's pretty sketch right there, big time, right? Like there's something.
Yeah, they tore it down. It's becoming a retirement home now.
Yeah, so there you go. Yeah, they tore it down. Probably better. We're better for everyone. All right. So, my hand up over here. Okay, great. Okay, so probably about zero gravity. We can just move on. All right. That's the deal. So if you run out of electrons, That's what I was talking about. If you run out of electrons here, we have no electrons left over, you got to double check to make sure everybody's happy. Okay, make sure everybody's got the number of valence electrons that they're looking for. So remember, one bond equals 2 electrons, right? If you have 2 bonds, you've got 4 electrons. If you got 3 bonds, you've got 6 electrons there, okay? Being shared. They're shared between both of those elements. All right, so let's go to nitrogen. Let's do this. We'll do a couple examples. All right, so nitrogen. We have 2 nitrogens. How many valence electrons does each nitrogen have? 5. So we've got a total of 10 electrons to dish out between our 2 nitrogens. So we don't really have, it just doesn't matter, right? Because there's only 2 atoms there anyway. So let's just put them out there, bond them together. I just used 2 electrons to do that. So I've got 8 left over. So we just start making them happy. Okay, so I'm going to start over on this side just because. 1, 2, 3, 4, 5, 6, 7, 8. That's 8. I don't have any electrons left now. Nitrogen on the left is good. 2, 4, 6, 8. Nitrogen on the right, though, we only have 4 electrons there. So we're out of electrons to add. What do we need to start doing? We're going to start sharing more, right? We got to rob Peter to pay Paul. All right, so you need to share electrons from the one nitrogen between the other one. So we're going to take a pair of electrons here. So I'm going to use that pair to draw another bond between the 2 nitrogens. The one nitrogen still has 2, 4, 6, 8 electrons around it. The other one, we're up to 6. Not quite there yet. Got to do it again. Still a lone pair of electrons there. And one more bond. There we go. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we got 8 electrons then. Good? Okay. All right, so both of them are good. That is a viable Lewis dot structure. Okay, let's go to the next one. We have 1 nitrogen. It's got 5 electrons. 3 times hydrogen. It's another 3. So we got a total of 8 electrons. Okay. Nitrogen in the middle, surrounded by hydrogens. We'll bond those guys together. So we just use 6 electrons. So we got 2 left over. Are the hydrogens on the outside happy? They are, they're good, right? Each of them have 2. All right. So any electrons you have left over, right? Any electrons you have left over and the outside atoms are happy, they go on the middle. Okay? So we put 2 electrons on the middle. It's 2. Down to 0. None left to add. Nitrogen good now? Yeah. It's got 2, 4, 6, 8 electrons around it. Okay. Okay. All right, great. All right, so let's keep on going. All right, so we have nitrogen. It's got 5. Oxygen has 6. Oh, positive charge on that. So that means we have to subtract 1 electron from our total. It's positively charged. So we've got a total of 10 electrons to dish out. So N bonded to O. So minus 2. I've got 8 electrons left over. I think you guys can see what's going to happen here. All right. 1, 2, 3, 4, 5, 6, 7, 8. Minus 8. All right. So we're down to 0. So once we run out of electrons, we got to try and make everybody happy still. What should we start doing? start double bonding, triple bonding, whatever we got to do to start sharing more electrons, sharing these lone pairs with each other. How many of you guys were in 312 last year for honors chemistry, or maybe you guys from that room right behind us here? The lone pair, were you introduced to the lone pair?
Like at the end of the year.
Okay, great. All right.
Oh, it's a long pair. Got it. So, like, again, second week.
That's pretty fun. All right. Good. Okay. I'll do this last one, PCl5, and then you guys have to do the other two. Okay. Okay, so PCl5. So phosphorus has 5, and we've got 5 chlorines for a total of what?
40. Maybe.
40 all day, but how many valence electrons for each chlorine? 7. So 7 times 5, 35, for a total of 40 electrons. Try to put phosphorus in the middle, right, because it's the least electronegative. Surround it with chlorine.
Oh, just when you have to do the shape, do the expand.
Yeah, we got 5 things going around here. We're going to bond them all to the middle. Right. So minus 10. Is it okay that we did this? Is it okay that there's 10 electrons around phosphorus? Well, the first inclination you should have is no, but then you got to double check. Because some atoms can have more than 8, right? Where is phosphorus on the periodic table? It's in the third row. All right, it's all good. We can have 5 chlorines around it. That's okay. Okay? Well, we just used 10 up. We've got 30 electrons left over. How many more electrons do we have to add to each chlorine? 6. Yeah, we got to add 6 to each one. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6. 1, 2, 3, 4, 6. 2, 3, 4, 6. 6 times 5. 30. And we don't have any left over. Yes, that's great. Okay, so are all the chlorines happy now? Yes, okay. Is phosphorus good? Yeah, it's got 10, so it's fine. It's got more than 8. That's that. Okay? All right, so the last two. You guys do the last two on your own.